Hi everybody. Today we're going to take a look at topographic maps, and I'm going to teach you how to read them, and we're going to go through some of the rules that will help them make sense. So right now you're looking at a topographic map, and it probably looks like a bunch of squiggles and lines and colors. It probably does not make too much sense to you. Here's another topographic map. Same thing. Probably just looks like a bunch of brown squiggles with some other colors thrown in there. By the end of the video, hopefully you're going to be able to look at a map like this and you're going to be able to see the topography or the shape of the land. So a topographic map looks like this one on the bottom, and basically what they do is they are a map that is able to show us the elevation, the height above sea level, and the shape of the land by using these lines, which are a kind of isoline called contour lines. So on the top, we have a landscape. You can see there's a cliff over here, there's a hill over here. When you know how to read a topographic map, you can actually look at this and you can tell that there's a cliff over here and there's a hill over here. Topographic maps have certain features that you will always see. So let's go through 4 of those features. The first thing you're going to have to figure out is what the contour interval is. When you look at a topographic map, you'll notice that not every line is labeled. For example, this map, we have 300 labeled and we have 400 labeled. Those lines are a little bit darker than the surrounding lines. Those numbered lines are called index contour lines. The reason they only label some of them is because we don't want the map to be too confusing. We don't want to have numbers everywhere. So the first thing you have to do is figure out what the contour interval is. In other words, what is the difference between each pair of lines? Now, sometimes they'll tell you the interval in a key under the map, but more often than not, you're going to have to determine it yourself. So if we start with this map over here, again, we have 300, and it's either meters or feet or kilometers. We're not sure with this map because it doesn't tell us. But we have 300 here, we have 400 here. So our task is to figure out what the contour interval is. What are we going to count by to get from 300 to 400? Now, hopefully, you're looking at this and you're realizing, well, it's a difference of 100 and it's spread out over 5 lines. So 100 divided by 5 is 20. So for this map, the contour interval would be 20 units. So by units, we mean either miles or kilometers or meters. Let's take a look at this top left map over here. So we're going from 10, and then we're skipping a line. It's not labeled. Then we're going to 20. So that one's pretty easy. We're counting by 5s. Okay. The bottom left map over here, okay, I see that this contour line is labeled as 50, and this contour line up here is labeled as 100. So again, it goes from 50 to 100, which is a difference of 50, and it's going 5 lines between them. So 50 divided by 5 is 10. And then on the last map, this one's pretty easy to figure out. We're counting by 25s. So our contour interval would be 25, whatever unit is being used. Let's take a look at another map. Can you figure out on this map what the contour interval would be? And feel free to pause the video. Well, hopefully you realized that we're going from 500 to 600. So we're going a difference of 100. And again, we're spreading it out over 5 lines. So we're counting with an interval of 20 meters. Once you know the interval, you can now figure out the elevation of any of the lines that are not labeled. So for example, line A, right over here, if we're counting by 20s, this line would be 540 meters. I want you to see if you could figure out what the elevation of line B would be. So think about that for a second. And hopefully you're realizing that it's 580 meters. Okay, so again, contour interval, first thing you want to figure out. The next thing that you'll notice on most maps is somewhere there will be a compass rose. And that's important because that will show you where north is. Normally, when we look at a map, north is usually up, but that is not always the case. You can see on this map that they're telling you that north is facing the right side of the map. So north is really here, and then south would be over here. So you want to look at the compass rose. You want to figure out where north is, where south is. So let's go through some of the rules of how to read a topographic map. Okay? Going back to this first map that we looked at earlier, I want you to notice when there's a cliff, what the contour lines look like. So right over here, where the land is steep, you probably notice that the contour lines are very close together. Okay? And that's always going to be the case. Rule number one is the closer the lines are, the steeper the slope. Or the opposite, the more spread out the lines are, the gentler the slope. We can see on the side of this hill over here, we have a nice flat area right over here. The land is pretty flat over here. And on our contour map, we can see the lines are spread apart much further than they were over there. Now on the back of your note sheet, you have this map. I want you to go ahead and I want you to figure out where the steepest slope would be on this landscape. Okay? So we're looking for where the lines are the closest. And pretty easy to see, the lines are the closest somewhere near the top over here. Okay, you can see how close together they are. Go ahead and label that on your map on the back of your note sheet. That is the steepest slope. Okay, rule number 2 deals with streams and rivers. When a contour line crosses a river or a stream, the contour line bends and forms a V. We can see that, again, this is the map on the back of your sheet. We have this Mill River over here, and we can see that when the contour lines cross the river, they are bending and they are forming V's. You always want to look for the V's because the V's will tell you where the water is coming from. So the tip of the V shows you the source of the water. So in this case, the water is coming from over here. This would be the source. And so the water is traveling from this bottom edge of the map. Okay? The river is flowing this way, okay, towards the ocean. And it eventually goes into the ocean, and that would be called the mouth of the stream or the mouth of the river. Let's practice that skill a little bit. That's an important skill. Let's take a look at this map. I want you to see if you can figure out which way Long Creek would be flowing. All right, so hopefully you notice the contour lines are bending, they're forming V's. And again, the tip of the V shows us the source of the water. So Long Creek is basically flowing towards the south, slightly west, so southwest or south. Here's another one. Let's look at Trout Stream over here. See if you can figure out which way Trout Stream would be flowing. All right, again, we look at our contour lines. They are bending, they're forming V's. The tip of the V shows us the source of the stream. So the water is coming from here, and it is flowing down this hill into the river. We can see the same thing when we look at the river. If we look at Cedar River, we have this one contour line here that forms a V. So we know the river is flowing this direction towards the lake. Okay, so that's how we figure out which way streams and rivers are going. Rule number 3. You'll notice this landform over here has 2 hills. When they're put on a topographic map, they look like concentric circles that get smaller and smaller inside of each other. Rule number 3 is that when there are rings of circles that get smaller and smaller, that it represents a hill or a mountain. So let's look at the map, again, that's on the back of your sheet. Let's figure out how many hills there are. Okay. So I see one over here. So let's go ahead, let's label that somewhere. If I click, there we go. So there's a hill. Can you find any others? Well, you should. There are 2 others. We have one hill over here where there are circles inside of circles. We have another one over here. This area down here on the bottom right-hand corner is not a hill. because it has these little marks on it, which we'll get to in a couple of minutes. Okay, so again, anytime you see circles within circles, it is a hill or a mountain. Okay? Now, what we have to do is we have to be able to figure out how high the top of the hill or the mountain is. So to do that, what we would do is we would look at our map and we'd figure out what our contour interval was. Now, we looked at this one before. So we know that this one's counting by 20s. This top contour line is 400, which means the top of the hill has to be higher than 400, but it's not going to be as high as what the next line would be. So the next line, if there was one, would be 420. So the top of this hill is somewhere between 401 and 419 meters, or whatever unit it is. So again, it can't be 400 and it can't be 420. It's got to be in between. How about on this map? Well, again, we're counting by 20s. So if this top line is 600, it means the top of the hill has to be somewhere above that, but lower than what the next line would be. So it's got to be somewhere between 601 and 619. Okay? So rule number 4 says the highest possible elevation of a hill is just below the value of whatever the next contour line would be, if there was a next contour line. Okay? So let's figure out what the height of these hills. Okay, so let's start with this one over here. So this contour line is 300. So let's figure out what we're counting by. So here's 200, here's 300. So we're counting by 20s. So if we come up the hill, so this is 300, 320, 340, 360, 380. So this small loop is 380, which means the top of the hill has to be somewhere between 381 and 399. It can't be 400, because if it was 400, we'd have another line there. So the highest it could possibly be is 399 meters. If we take a look at this hill, we could figure out the same thing. We could figure out the same thing down here. Okay? So in this case, here's 200. So the circle where letter Z is, that's 220. The next line would be 240. So the elevation can't be that high. It's got to be underneath that. So the highest would be 239. All right, moving on. Rule number 5. Sometimes we don't have a hill. Sometimes the land dips down and forms a depression. So this is the top of a volcano, and there's a crater up here. That's a depression. On a contour map, we show depressions by using these little marks that are called hatchers or hatch marks. So again, we'd find these where there's a volcanic crater, or maybe a meteor hit the earth and left a crater. So on your map, we see that right over here we have a depression. So these little hatcher marks tell us that the land is going downwards. Okay? Now the last rule, the 6th rule, tells us how we would figure out how deep the bottom of the depression is. Okay? So the first part of the rule says that when you're at a depression, the first hatchered line, so the outer circle, has the same elevation as the previous contour line. So in other words, this line over here has an elevation of 120 meters. So our first line with the hatcher marks is also 120 meters. Then what we do is we start to go downwards. So if this is 120, it means the next line is going down by 20, so it's going to be 100. To figure out the deepest that this depression could be, what we do is we say, all right, if there was another line, what would that be? So if there was another line, it would be 80, but that line's not there. So this depression can't go down to 80. So it's got to be a little bit higher than 80. So the lowest possible elevation is just above whatever the next contour line would be. All right, so here's another contour map. Hopefully you can use some of the rules we went over, and you could figure out some of the topography, some of the shape of the landscape. We're going to be doing a lot of this in class. Have fun!